Today we're going to explore chops and parameters. And to do so, we're going to make this unusual little animation here. So we have three balls, red, green, and blue. The red ball we're going to animate using keyframes and expressions. But for the green and yellow spheres, we're going to use chop networks to make their motion. Specifically, what we're going to do is we're going to create a chop network to extract the motion data from the red ball, make some changes to it, and then apply that updated motion to the green and yellow balls. So let's stop this animation, exit full screen, and dive in. First thing I'm going to do is delete this demo that I had prepared. And let's next minimize the panels that we're not going to use on the technical desktop. We're not going to use the tree view or the Python shell, and we're not going to use the toolbar. So there we go. First, create a geometry node, and let's call this chop demo. Let's dive inside and very quickly make three spheres. Once you have one sphere, if you hold down Alt and drag to the right, it'll make copies for you. And then let's give them all the color that they need. The first sphere, let's make this the green one. Once again, we can select this node, hold down Alt, drag it over. Oops, didn't mean to make those, wire those together, so I'll just use Y and pull up the scissors. Connect those. So here we go. The first one will be green. The second one will be yellow. And the third one will be red. Okay, let's clean this up. And to do that, I'm going to go in full screen mode. So with your cursor over the network view, use Control B. And here we go. So we'll select the three color nodes and we'll just merge them all together so we can see all three spheres at once. And let's rename them. This will be the green ball, yellow ball, and red ball. And for the colors, we'll call them green, yellow, and red. There we go. Space these out a little more so you can see the names of all the nodes. Exit full screen by using Control B. And there we go. Now, where are they? It's because, well, we have the three spheres stacked on each other. So let's go ahead and take the green ball and move it in the negative x direction 5 meters, and the red ball and move it to the right, the positive x direction 5 meters. So there we go. We have our geometry. Now let's dive into the animation. For the red sphere, let's select the red ball. We'll first just move it in the negative z direction 20 meters over the course of the animation. So at the first frame, we will create a keyframe for the Z position using Alt left click. We'll jump to the end, move this red ball to negative 20 meters and Alt left click again. And there we go. If we go to the beginning and play this back, you see the red ball move, but it does have the acceleration and deceleration, which I would not like for this demonstration. So let's fix that. So with the red ball selected, go to the animation editor and let's click home so you can see it. So here is the path for the TZ value. The TZ, by the way, if you right click, you will see that it's called a channel. So remember, a channel is just a list of numbers. So far we've created a channel with two numbers, 0 a time t equals 0 and negative 20 a time t equals 10, or at frame 240. So here from the shape of this, you can see the acceleration, the constant speed, and then the deceleration. Let's just select this path, come up to the top and click this line, and now we have just a straight motion. We don't have any acceleration or deceleration. Play that back just to verify. That's what we want. Now let's add the wobble up and down. To do that, we're not going to use keyframes, we're going to use an expression. And whenever you have this oscillation motion, that's when you need to use the sine or cosine function. So I'm going to use sine of the time. Play that back, and you can see it is now going up and down, but the up and down motion is quite subtle, and also it's not going up and down very quickly. So let's fix that real quick. If we go back to the expression for ty, Let's increase the amount it goes up and down. That's the amplitude, and the number in front of the sine function controls how big the swing is. Let's just double it and see what we think of that. That's good, but we could speed up the oscillation as well. To speed things up, you're going to go inside the sine. This controls the frequency. The bigger the number you have here, the multiplier, the more frequent the oscillation is going to occur. So let's just have it oscillate twice as fast. There we go. So now we have the motion that we desire. The motion in the negative z direction is controlled by keyframes, and the up and down motion in the y direction is controlled by an expression. So what we now are going to do is we're going to learn how to use chops to extract this motion data, work with it, make some alterations to it, and then apply it to these other two. So let's come back to our network view and do Control B for full screen. So I am going to create a chop network. You can create this here. You can also go up at the scene level and create a chop network there. But I like to have the chop network next to the geometric objects or what have you that I'm going to be manipulating. Now I'm going to call this green yellow motion, because this chop network will control the motion of the green and yellow balls. Now, if you go into the chop network, it's empty. The first thing we want to do is use a channel operator, a chop node, to grab the motion data from the red ball. If we exit this and play it back again, let me talk a little bit more about that. So for the red ball, if we select the red ball node, you can see there's a lot of different parameters here. The only parameters that are actually changing over time are the y and z values. So if you move your mouse over the word center, let's go ahead and stop this actually. If you move your cursor over the center parameter, you'll see it lists three parameters, tx, ty, tz. Each one of these is also a channel. It's a sequence of numbers. The first one, tx, the tx channel is the number 5. It doesn't change with time. So the ty channel does change with every passing frame, and the same with the tz channel. So the idea is that each parameter is a separate channel. So does that mean channels and parameters are the same thing? Not exactly. Parameters are basically channels that are attached to nodes, but you can have a lot of channel data that aren't attached to a specific node in your network. So return full screen and go into the chop network. So let's begin by grabbing the motion from the red sphere. To begin, we're going to hit Tab, bring up the pop-up menu, and we're going to come down to Import. We are going to import parameters. So we're going to use the Fetch Parameters node. Now for this, the first thing you want to provide is what node do you want to grab data from. We're going to grab data from the red bulb node. Now if you come to this node and hit the information button, you will see there's 22 channels that it imported. It might be a little bit of a surprise. If we expand it, here's the names of all the channels that it imported from the red ball. Type, surf type, rad, XYZ, TX, TY, TZ, and so on. Let's see where these 22 channels came from. Exit full screen. Let's go up a level, and we're going to select the red ball. Let's expand the parameter panel here so you can see all the parameters that we can adjust for the red ball. If you count them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There are 22 different parameters that can be adjusted in this panel. Each one of those is a channel. Each one of those is a sequence of numbers. And if you mouse over any one of the parameters and just wait a moment, it'll give you the name of it. So like here, there's a parameter called rows. Down here, there's order U, order V. So if we go back to the chop network, full screen with Control B, and look at the channels, you'll see that there they are, rows, columns, order U, order V, and so forth. We're interested in the position data, TX, TY, TZ. We don't want the other 19 channels. So what do we do? Here, inside the next parameter says what channels do you want to import, and we use the asterisk. The asterisk is a pattern matching string. What that says is everything. Bring in everything. So for example, if you want to bring in everything that starts with the letter T, you could type in T and then a star. And if you come over to the fetch node, you can see now there's 5 channels instead of 22. It brought in TX, TY, TZ, but it also brought in type and triangular poles. So what should we do? There's some fancy ways to do it, but I think the most clear way is say we want TX, TY, and TZ. Come back and click the information for this fetch, and you can see there's 3 channels. TX, TY, TZ, they're the names of the channels. For each one, it shows you what the min and max values are, and also gives some more interesting data about each channel. There's 24 samples per second, or 24 values in each channel per second. It's a 10-second animation, so that's 240. The frames are numbered from 1 to 240, but the data is numbered from 0 to 239, because in programming, you always start numbering things with 0. You don't start with 1. So that brought in the channels. Is there any proof that something has happened? If we come to the animation editor, nothing. The animation editor is not where you look at raw channel data. What you want to look at is the Motion FX View tab. That is the viewer for you to be able to view the data inside these channel operators, all the chop nodes. Right now it's empty, so we need to come over here and turn on the display flag. And there we go. We have 3 graphs, one for each channel. There's the TX channel, the TY, and the TZ. Remember, when we animated the red sphere, the X value didn't change. It wobbled up and down in the Y direction, and the Z value went from 0 to -20. So there we go. Let's return to our chop network. What I would like to do is I would like the yellow sphere to move in the Z direction along with the red sphere. So how do we do that? There is an export node. And the export node asks, well, what channels do you want to export? Meaning take the data from this channel and put it somewhere else. We want to take the TZ, the Z data. We are going to apply it to the yellow ball. And notice the path. It's like, okay, for the yellow ball, which parameter should we overwrite with this data? It defaulted to TX, but we want it to overwrite TZ. Let's leave full screen. Go to the scene view. Go up a little bit in our network, and let's play back and see what happens. Okay. Nothing happened. We were hoping that the yellow sphere would move along with the red sphere, but it hasn't happened. And the reason is in these chop networks, there's this one extra flag here called export. You need to turn on that flag to say, okay, take the data contained within this chop and copy it over to the destination. So let's turn that on. Now we have this orange flag, and if we play it back now, there we go. The yellow sphere is moving along with the red sphere at the same speed. The red sphere also has an up and down wobble, but they are moving in the Z direction at the same speed. Let's stop that. Now, by the way, if you come up here and select the yellow ball, I'd like to point out something. Look at the parameter for the Z value of the Z position of the yellow ball. It's green, but there's this orange stripe at the right. This orange stripe lets you know that it's under the control of a chop network or a channel operator. Because when you dive in here, when we exported it, we turned on the export flag and see this color, it's an orange color. If you go back up, click on the yellow ball, this is the color right here. So this green typically lets you know that the values are changing with time, either by keyframes or expressions. But in this case, it lets you know that the Z position of the yellow sphere is changing due to a channel operator, to a chop. There we go. So now let's add the up and down motion to the green sphere. Let's go full screen on the chop network here. What we're going to do is we could use another export node. We could export the TY channel from the red ball and apply it to the green ball, but I want to show you a different way to do it. So let's delete this. And what we're going to do is first, we're going to delete the channels we don't want to use. On the delete chop right now, it deleted all channels to start with the letter T. Okay, let's go ahead and get rid of that. So now if we look at the information for the delete chop, it has the 3 channels that were fed into it, TX, TY, TZ. We're interested in the up-down motion, so we're interested in TY. So we're going to delete TX and TZ. So let's delete TX and TZ. Now we can see that there is just a TY channel. So we have a TY channel, and what we're going to do is we're going to rename it. And we're going to rename it to the path to the TY value of the green sphere. So we're going to rename it from TY to, and we're going to have to exit full screen here and bring up the tree view. In the tree view, the path to the Y position of the green ball goes from OBJ into our chop demo node to the green ball to the TY parameter. That's the full path to that number. So if you go into the chop network, come to the rename mode, we're going to rename TY to the path OBJ chop demo green ball TY. Think of this as the absolute path that you navigate to get to the Y position of the green sphere. Now, if we play this back, once again, we're hoping the green sphere would go up and down in sync with the red sphere. It didn't happen, and it's because we have to export it. So how do we do that? If we hit export on, let's go full screen, Control B. If we click the export flag on the rename node, it no longer displays on the export. If you click on the export here, so it's kind of like the problem in geometry networks where only one node is selected as the output node, but there's a way around that actually. You just have to shift click. So we want this to export, and if you hold down shift and click this, this means we want that to export as well. So we first fetched the position data from the red ball. On this branch of the network, we exported the Z value to the Z value of the yellow ball. Here, we deleted the channels we didn't need, and then we renamed the channel to the absolute path to the Y position of the green ball. If we leave that and play it back, now we see all 3 balls are in motion. So we've successfully taken the wobble motion from the red sphere and applied it to the green one. We've also successfully taken the Z motion of the red ball and applied it to the yellow one. But what we're going to do now is get a little bit fancy. What I would like to do is I would like the yellow ball to be moving twice as fast as the red one. And I'd like to add a little bit of jitter to the green sphere. So let's stop, come to our chop, and let's speed up the motion of this one, of the motion in the Z direction. The way we're going to do that is we are going to insert a math node. The math node allows you to do certain calculations on your channels. Now, the math node is being fed 3 channels, TX, TY, TZ. If you come up to the Common tab, there's this thing called Scope, and that means whatever we do here is going to apply to every channel. But we really only want to affect the TZ channel. So what do we want to do? We would like to multiply it by 2. So let's come to the math node and look at the information panel for it. There are 3 data channels, TX, TY, TZ. The X value never changes. The Y value changes roughly from -2 to 2. There's a little bit of, it never gets exactly 2 because it's never exactly 2 or -2 on a frame number. And the Z value goes from -40 to 0. But look at the min and max for the red ball. The Z value is -20 to 0. Min and max is 5, and the Y min and max is the same as well. So we can see, in fact, that this math node, the only change that it made was for the Z value, it doubled the values of all the numbers in the TZ channel. So having done that, we then export this TZ channel that's now been doubled to the yellow sphere. If we play that back, that means the yellow sphere should move twice as fast as the red sphere. And it does. If we look at it from the side, zoom out a little bit here, you can get a better view. There we go. You can see the red and yellow spheres moving to the negative z direction, and the yellow sphere is moving twice as fast. Next, we would like to add a little bit of noise, a little bit of jitter to this green ball. So how do we do that? Stop, come back to our chop, and we are going to create some noise. So let's drop in a create chop, and let's come to the motion FX view. Let's close this. Now, you can set the display flag on any of the chops that you like, but after a while the graph will get pretty messy. So let's select them all and click the display flag, and that turns it off for everything. So that's a nice shortcut to remember. What we will do is display the data from the red ball, and let's display the noise. So here we have a little bit of just kind of random looking noise. Let's actually hide the red ball position and focus on the noise for now. You can adjust the amplitude of the noise. Let's do that. And then also the period, or also how frequent does the noise seem to be occurring. If the shorter the period, it seems a little more staticky. It's happening a little more rapidly. So that seems like a good amount of noise. And let's just dial down the amplitude a little bit so the noise isn't as big as the up and down motion. So there we have some noise. So how do we mix it to the Y position? One way to do this, there's always more than one way to do things in Houdini. Let's go full screen on our chop network, is we're going to take this fetch node and merge it with this one. Now, when we merge these two together, let's go ahead and cut, holding down the Y button, let's cut these. Okay. Now when we merge these together, the fetch gives us TX, TY, TZ. The noise gives us a channel called Chan1. That's not actually a very descriptive name, so let's fix that. You select the noise channel, come over here, select the channel tab, and let's name this wiggle. And it's just noise instead of noise 1. So merge takes the 3 channels from the fetch, the 1 channel from the noise chop, and combines them together, so this chop now has 4 channels of data. And you can see there's 4 channels up here, and their names are TX, TY, TZ, and wiggle. Now, the branch over to the yellow node that gives it the twice as fast motion of the Z direction, we don't need to change anything there. But let's come over to this direction, to the left branch. What we'd like to do is we'd like to take the noise that we generated and add it to the TY channel. To do that, we're going to use another math node. So when you select the math node, if you come over here and select the Common tab, the scope parameter says what channels do you want me to use in doing the mathematical calculation. We want to take the TY channel and the wiggle channel. If you don't have the names memorized, you can start blank, click the drop down and say I want to use TY and I want to use wiggle. So those are the 2 channels I want to use. So we're going to come to the OP tab, the operation tab, and we want to combine those. And if you click that, we just want to add those 2 channels together. When you do that now, we have a single channel, TY. So what it did is it took the TY channel from here, the wiggle channel, added them together, and the result is just 1 channel, which we called TY. But we want to rename that. So let's get rid of the delete one, because now at this point we have only 1 channel of data and its name is TY. But if we rename it, down here we rename TY to this, we should be good to go. So let's exit full screen mode, go to scene view and playback. And there we go. So let's do a quick recap and really understand what is happening here and what we did. We're going to look at this chop, and let me tidy things up here. I'm going to take these 3 nodes and select layout and align them vertically. And bring this over here and let's line these up vertically. Just like to have tidy networks. And we'll put the merge node here. So we have a network here in this chop network with 7 chops. The first one, fetch, says fetch parameters. Remember, there were 22 parameters for the sphere. We only wanted the ones controlling the position, tx, ty, tz. So we said go to the red ball and fetch these 3 channels. Initially with the asterisk, it fetched all 22, but we only wanted those 3. The noise doesn't go and get the noise anywhere. It actually is creating channel data. And we wanted to give it a useful name, so we called it wiggle. We then, here the merge combines the 3 channels from here, the 1 from here, into a chop with 4 channels of data. Now we wanted to branch off and control the 2 balls separately. So what we did here was, let's double Z speed. That's a useful description. And let's, to describe the export, we exported this to yellow TZ. So what this did was, in the comment tab, it said, okay, what channels do you want to work with? We wanted to work with the TZ channel. And what we did was we wanted to multiply it by 2. This is, here you can add and multiply and change certain channels before you do anything else. We just wanted to double it. And then the export node said, export the TZ channel to this node and overwrite that value. And you also had to be sure to turn on the export flag for that to happen. Now, when we branched to the left, this was for the green TY value, was add TY and noise. So these are pretty descriptive nodes here. And so for this math node, it's being fed from a chop with 4 channels. We did the same thing. We came down and said, okay, scope. Let's restrict the operation of this chop to just these 2 channels. And the operation is add the channels together. Once we did that, we were left with just a single channel of data, and it was called TY. So all we then did was rename TY to the absolute path to the Y position of the green ball and made sure that the export flag was on. So there we go. We created our geometry. We generated the motion using keyframes and an expression, and then using the magic of chops, we were able to work with the motion data and see what you have here. Now, in future videos, what we'll do is we'll get a little fancier with this. Well, this right here you could do with expressions, but if you were to take, for example, the data from a piece of music and want to work with that and use that to have like maybe a particle field move and sync with the music or something like that, chops will really help you out there. But I hope this gives you a good understanding of how basically every parameter on a node is a channel of data. And in chop networks, you can fetch these channels, work with them using some math as you'd like, combine some things together, and then apply those to other shapes.